Hello. In my last lecture, I discussed about emulsions and gels, two colloidal systems which are very interesting systems. In all the earlier lectures, our concentration was on salts. Therefore, it was necessary to mention about gels and emulsions. Now, it's time for us to look at the applications and importance of colloids. We live in a world where colloids are an important part of our life. Take it medicine, food, jewelry, industries, soaps, detergents, water purification. The list is very long. Artificial rain, you will be surprised, where colloids have a role to play. Rubber industry, rubber plating, leather tanning, smoke screen, and several other natural phenomena like blue color of the sky, metallurgical operations, oil recovery. Several applications in diverse areas are there. Finally, I will summarize the applications of colloidal dispersions. As mentioned earlier, colloids have very important applications in our daily life, starting with the food products that we use in modern cookery and medicines, then lot many industrial products of daily use like toothpaste, cosmetics, detergents, rubber, and several other things. Just to give that colloids are part of our life, you will be happy to know that animal cells, including humans, and plant cells have colloidal systems. Blood itself is a colloidal system. Let's start with the foods. Many of the food materials which we eat are of colloidal nature. Milk, butter, ice cream, cheese, bread, jelly, as you see them here, they are attractive. Earlier, when colloidal science had not developed, we had limited use of materials. Now, once the colloidal system has been understood, we get variety of foods very attractive to look at, like the jelly that you can see here. Medicines. Without knowing, we have been taking medicines for different ailments which are colloidal in nature. Why colloidal? Because in this form, they can be assimilated very easily by the body. For example, the medicinal formulations that we take are emulsions or salts. Colloidal gold and calcium are administered as injections in order to raise the vitality of human system. Some major antibiotics like penicillin and streptomycin are injected into the body in the form of colloidal salt. Just to give an example, what happens in our body, digestion of fats in the intestine is facilitated by emulsification. A small amount of fat reacts with the alkaline solution in the intestine to form sodium soap, which then emulsifies the rest of the fat, and this facilitates the digestion of fats by the enzymes which are there in the system. Jewelry, very attractive application. Naturally occurring gems tell us something about the unique nature of these colloidal systems. They look solids, but they are actually not solids in the real sense. They are colloidal dispersions of one solid into another solid, the so-called solid solutions or solid salts. We also use several other products in our daily life. We cannot go into the details of it. Some of them are shown here. The toothpaste that we use in the morning, the glue that we use to stick, and also varnishes that we use these days are all examples of colloidal dispersions. Think of a bath without soap. You cannot imagine. And you get in thousands different varieties of toilet soaps to your choice. Then we have washing soaps, detergents, you must know the difference between soaps and detergents. For washing, detergents are better than soaps. You will find the reasons elsewhere when you study soaps and detergents in organic chemistry. Industrial detergents. When we talk about detergents, we only recollect the soap that we use at home. But industrial detergents are produced in large quantities and used in tons in industries for cleaning purposes. Whitening agents. The clothes get dull, then we need to whiten them, and we use a colloidal system in order to retain the whiteness. Water purification. We can definitely understand the importance of water purification. At times, water supplied through the taps by the corporation or the municipality is found to be turbid. The turbidity is due to the presence of fine clay matter, especially in the rainy season. If you look at the ponds in villages, it is muddy. The villagers need to use this for all their uses, including drinking purposes. Turbidity cannot be removed by filtration. However you may try, turbidity is retained because it is colloidal. We can use our knowledge about colloid chemistry. The electrolytes like alum or aluminum sulfate, even salts of iron can help remove turbidity. For example, aluminum 3+ ions bring about coagulation of the colloidal matter present in water, which settles down and can then be removed by filtration. The process is called flocculation. When we add alum to the muddy water and stir it well and allow it to stand, you will see that the coagulation takes place. The particle size of the colloidal dispersion that is present grows in size. The process, as I told you, is called flocculation. They form flocks. They are large enough. They start settling under gravity, finally to the bottom of the vessel in which water is taken. The water above, that is the supernatant water, appears clean, which can then be decanted and taken out and boiled if necessary for our daily use. Sewage disposal. But another problem faced by the corporations and municipalities is sewage disposal. Lot of water can be recovered and used for different purposes. Sewage treatment requires special efforts. The sewage water contains impurities like mud, dirt, which are colloidal in nature, which are dispersed in water, and these colloidal particles of sewage carry electric charge, and hence again our knowledge about colloid chemistry can be used here. So we can use our knowledge about electrophoresis in order to remove these charged particles from the sewage. For this purpose, the sewage water is passed through tunnels which are fitted with metallic electrodes, and a voltage is applied across it, and when this happens, the colloidal particles migrate towards the oppositely charged electrodes and get discharged. Whatever material that is collected near the electrodes can be removed, and we can use them as manure. Smoke precipitation. In the cities and in the industrial areas, a serious problem is given by the smoke, maybe due to industries, maybe due to the use of old methods for cooking using firewood, maybe because of automobiles which have increased in large numbers. These add to air pollution and it is harmful to health. Many of the people suffer from lung diseases. So, removal of these dispersed colloidal particles from air will help reduce the problem, both health and aesthetic. We know that smoke is an aerosol which mainly consists of charged particles of carbon dispersed in air. As the particles are charged, we can again use electrophoresis to remove these charged particles and prevent them from getting into environment. How do we do it? This is done in industries using a setup called Cottrell Precipitator. The process is named after its discoverer. The smoke is passed through a chamber which contains a number of metal plates or electrodes attached to the metal wire connected to a high potential, which is about 50,000 volts. You can see the construction of the Cottrell Precipitator. The central wire here is maintained at high voltage. The outer compartment is connected to the earth. The smoke enters and it comes into contact with the metal wire at the center. Particles being negatively charged, they get discharged at this wire, they grow in size and then start falling to the bottom of the chamber. The air or the gases that are freed from particulate matter then escape and are let out into the atmosphere in industries through the chimneys. Artificial rain. Interesting it is. Why it is interesting? We know that clouds are colloidal systems consisting of water vapor of colloidal dimensions which are charged, and also there could be dust that is dispersed in air. How the rain is caused? The small colloidal particles of water vapor aggregate, become heavy and then fall as rain. If there are clouds but no rain, what do we do? Artificial rain, and it can be done by spraying charged particles in the form of, say, sand or electrolytes, which neutralize the charges on the water particles or water vapor particles of colloidal dimensions. Rubber industry. You can look at this figure. Those who are from the south are familiar with this. This is the rubber tree. If you pierce the trunk of the rubber tree, a white milky liquid oozes out, which can be collected in the vessel. This is the latex, a colloidal dispersion of rubber particles in water. It is an emulsion, and the system is stable enough and can be stored for some time. For obtaining rubber, this latex is boiled or treated with electrolytes to bring about coagulation of rubber particles present in the latex. The coagulated mass, which is called the coagulum, is then filtered, dried and rolled into sheets. These sheets are then supplied to the rubber industries, where they are processed with a lot of other ingredients like sulfur, etc., carbon black, to form various rubber products. And one main application you can see in making tires. Rubber plating. Here we employ our knowledge of electrophoresis. Latex particles are negatively charged and they can be made to deposit by electrophoresis onto wires or handles of various tools in order to insulate them or provide a grip to the tool. The article to be rubber plated is made the anode. The colloidal rubber particles migrate in the electric field towards the oppositely charged anode and get deposited on it, forming a layer. Leather tanning. You can see the diverse nature of the applications for the colloidal systems. Tanning is a process of treating the skins of animals to obtain leather. Skin of the animals is also a colloidal system in which the colloidal particles are positively charged, and in the process of tanning, the charged particles of skin are coagulated using positively charged materials like tannin or the compounds of aluminum or chromium as the electrolytes. Cleaning action of soaps. You have come across this many times. Soap solution is a colloidal system. When put in water, it forms micelle, and because of it, It is able to remove oil and dirt. Oil and dust particles are solubilized in the core of the micelle and removed while we rinse the object with water. Then the surface is left clean. Smoke screen. You might have come across this term if you had undergone training in NCC. Smoke screens are used to hide something by a layer of smoke. Especially in the sunlight, these smokes show the Tyndall effect and the visibility can be reduced to almost zero. It is generally used in warfare to hide or camouflage the movement of troops. So if the enemy is across, if you have a smoke screen, you can move and station yourself in strategic positions, and this can help you to win the war. The smoke screens are colloidal systems in which the particles of titanium dioxide are dispersed in air. And you can know why the smoke screen is formed because of Tyndall effect. Formation of delta. You know what delta is. You can see this picture here. Extensive deposits of sand and clay formed at the mouth of any river in the sea at the site where the river gets into the sea are called delta. How deltas are formed? It's very interesting natural phenomenon. The negatively charged colloidal particles of clay are neutralized by positively charged ions present in seawater, leading to coagulation. The clay particles get deposited, ultimately leading to the formation of delta. It may take several years for the formation of delta, but you can clearly see that. And in some cases, islands may prop up from the sea. Sky is blue. Why it is blue? The blue color of the sky is due to the scattering of blue color of sunlight by the colloidal particles of dust that are dispersed in air. Dust is always present in the atmosphere, and scattering of light by colloidal particles is known as Tyndall effect. Therefore, the color of the sky is blue because of Tyndall effect, a property that you have studied. And blue color is scattered more, and hence it looks blue. You may ask, why not other colors? Because white light contains 7 colors, then why only blue? The reason is that blue is the favored color because of its wavelength. Preparation of nanomaterials. This is the day of nanotechnology. Nanomaterials are becoming fashion. They are finding applications in various areas, and one of the methods that is employed for synthesis of nanomaterials uses our knowledge on colloidal systems, that is micelles and reverse micelles. One of the methods for preparing the nanomaterials is based on reverse micelles. We will not go into the details of it. Metallurgical operations. We use what is called flotation process for treating sulfide ores. It involves the treatment of the ore in the form of an emulsion using pine oil. The figure here gives us the principle used in froth flotation. The emulsion of pine oil and water is here. Air is forced through this arrangement. In this, the ore which is finely ground is suspended, and because of the air that is bubbled through, a froth is formed which carries those particles of ore to the top along with the froth, and the gangue settles to the bottom. Application of emulsions. Digestion of fats in the intestine is facilitated by emulsification. How? The fat that is present reacts with the alkaline solution of the intestine to form sodium soap. This soap that is formed emulsifies the rest of the fat. Once it is emulsified, the digestive enzymes can easily carry out their function in a better way and get the fat digested faster and easier. Oil recovery. It's a big business in the petroleum industry. In spite of several applications useful in our daily life, formation of emulsions sometimes may cause difficulties. One difficulty is faced by the petroleum industry Some of the wells yield emulsified petroleum instead of petroleum alone, and in such a case de-emulsification has to be carried out, and our knowledge about de-emulsification, how to make an emulsion unstable, can be used in order to separate the constituent liquids, that is water and petroleum. Let me summarize the long list of applications that we have seen in the food industry, in the pharmaceutical industry, in our daily life, especially the soaps and detergents, water purification both for drinking purpose and in the sewage disposal, in reducing air pollution by using Cottrell Precipitator to bring about artificial rain, in rubber industry, leather industry, and in warfare, in the explaining the natural phenomena like formation of delta, color of the sky, why it is blue, in the laboratory and industry for preparation of nanomaterials, in metallurgical operations, and applications of emulsions in our body systems as well as oil industry. With this, we come to the end of our discussion on colloidal state. We started with the explanation of the colloidal state, why it can be considered as the fourth state of matter, how colloidal systems are different from true solutions and suspensions. We looked at the classification of colloidal systems, how can they be prepared, and once prepared, how we can purify them. We looked at various methods. Then we looked at the important properties of colloidal systems, and finally we looked at many examples of colloidal dispersions in our daily life, in industry and elsewhere.